So today we are going to talk about inverse trig functions. You did work with them a little bit in your homework over the weekend to find angles. You've seen them before, but we're going to talk about them in a little bit different context than just finding an angle in your calculator. Okay, so first of all, inverse trig. If we have y equals the sine of theta, then the inverse of that, the inverse sine of y equals theta. Okay? So that's the relationship. Okay? In your calculator, when you did your homework, when you use the inverse sine button or the inverse tangent or the inverse cosine, your calculator gave you an angle. Okay, that's an important thing to realize, I guess, is that when we're doing the inverse trig function, we are finding an angle. Okay, before we could say the sine of 30 degrees, the sine of 180 degrees. Now we're saying the inverse sine is going to give us an angle. Okay, so we're actually going to talk about what the graphs of inverse sine and inverse cosine and inverse tangent look like. You are not going to have to graph these, but it's important to know the domain and range so you know how to evaluate. All right. So here we go. It's supposed to be a screen share. There we go. Okay, so the inverse sine. Let's talk about what y equals sine of theta looks like. What does it look like? Like this, right? Over and over and over and over again. Now, when we talk about inverse functions, we take our graph and we reflect it about what? Not quite. Not quite. What did you say? Yeah, the diagonal line, y equals x. Okay? So if we take this and we reflect it about the y equals x, this is what we get. We have a problem. What's the problem? It's not a, you're thinking of the right thing, but it's not a function. It doesn't pass the vertical line test. Okay? So in order to have an inverse sine, we have to have very specific restrictions. Okay? So first of all, I want you to understand the notation. You are used to this. Y equals the inverse sine of x. Here is a new one for you. Arc sine, it just means the same thing. You're used to seeing sine inverse. Arc sine is the same thing. Okay. So what mathematicians did with this, they said, okay, let's look at the origin. Where, like, what piece of this can we pick out so that it passes the vertical line test and we still have positive and negative values? So here at the origin, okay, here we have some positive values, here we have some negative values. And if I continue on anymore, we're not going to pass the vertical line test. So this is what the inverse sine function looks like. It's just a small piece of that graph. Okay? And we can't continue anymore, otherwise it won't be a function. So this is the inverse sine. Okay? Now this is what I want you to notice and understand about the inverse sine graph. What is the, what do we talk about first? What's the domain? Oh, that's kind of familiar. How does that relate to y equals the sine of x? That is the range. Remember when we talked about inverses, domain and range are switched. Okay, Okay? So since the range of sine of x is negative 1 to 1, the range of the inverse sine is negative 1 to 1. Okay? Now the range can't be all real numbers, otherwise it's not a function, so we restrict the range. What is the range restricted to? Yeah, negative pi over 2 to pi over 2. You knew what you were trying to say. Okay? So what I want you to think about, negative pi over 2 to positive pi over 2. Okay? If we think about the unit circle, here's 0, here's pi over 2, and here's negative pi over 2. Okay? So what's happening is we are getting values from the first quadrant or rotating negatively to the fourth quadrant. Okay, so here are the values we're getting from the unit on the unit circle. If we had to evaluate one of these without a calculator, okay, we're positive in the first quadrant, we're negative in the fourth quadrant. Okay, but we don't use 7 pi over 4. Okay, that's not in the range. We'd have to use negative pi over 4 and negative pi over 3. Okay. We will come back to that in a little bit. Okay, we're going to talk about inverse cosine, and inverse tangent, and then we'll talk about evaluating these. Okay. Okay, inverse cosine. Talk about what that's going to look like. Okay, so here is y equals cosine x, right? And we know that it goes on forever and ever and ever and ever and ever, right? Okay, so now let's imagine flipping this across the line y equals x. What's that going to look like? Okay, so here's 1, right? It's going to correspond, instead of 0, 1, it's going to be 1, 0. We have that same issue, right? Where it doesn't pass the vertical line test. So we can only take a piece of this for our actual function. So we need to restrict the range, basically. Okay. So what we do is we take this piece where cosine is positive and this piece where cosine is negative. So this is what the graph of the inverse cosine looks like. Okay? And remember, we have inverse cosine or arc cosine. We can notate it either way. So like arc sine, arc cosine has a domain of negative 1 to 1 because that's the range of the cosine graph. Okay. What is the range of this one? Where do we have values? 0 to pi. Arc cosine is kind of the oddball because its range is 0 to pi. If we think about our unit circle, okay, here's 0, here's pi over 2, and here's pi. So we're going to get positive cosine values from the first quadrant and negative cosine values from the second quadrant. Okay. Now, our arc sine had values in the first quadrant and the fourth quadrant. What's true about the cosine values in the fourth quadrant? They're positive, okay? So that's why this, the arc cosine is kind of the oddball out. And you'll see what I mean when we talk about arctangent. But arc cosine is the only inverse trig function that we're going to get values from this first and second quadrant, okay? Its range is 0 to pi. All right. Last, but certainly not least, we're going to talk about inverse tangent. Okay? This one is actually pretty cool. Oh, I actually got the screen share on this one. Okay. So, let's talk about what the tangent function looks like. What does it look like? We have asymptotes, right? Where are our asymptotes? Anybody? Where are the asymptotes on y equals tangent x? Thank you. Not quite. So you try? Josie, do you remember? What? Yes, the edges of the frame. And so if we're talking about the parent function, where would those be? Yes. Pi over 2 and negative pi over 2. Okay? So that is the graph of the tangent. Now let's talk about the inverse tangent. Here are our two notations. What's going to happen when we rotate that about the line y equals x? Okay, these are going to switch, right? Look like this. So our vertical asymptotes become horizontal asymptotes. Okay. Since the range of y equals tangent of x is all real numbers, that is the domain of the inverse tangent. Okay. Now our tangent function, we repeat these over and over and over and over and over again. Now, we can't do that with the inverse tangent, otherwise we wouldn't have a function, so we only have one of these snake-like shapes, if you will, in between two asymptotes. Okay? And so our range is negative pi over 2 to pi over 2. Now, we cannot include negative pi over 2 and pi over 2 because we have asymptotes there. Okay? But what I want you to notice is that this range is very similar to the inverse sine range. Okay? If we think about our unit circle, 0, pi over 2, negative pi over 2, we have positive tangent values in the first quadrant, negative tangent values in the fourth quadrant. Our range, that's where we're pulling values from, the first and fourth quadrant. So we're going to go through some examples. We're going to go through 6 examples of unit circle values. Okay? So here we go. Our first one, the arc sine of negative 1/2. So this is asking you, what angle is the sine ratio negative 1/2? Okay. Now, something we need to keep in mind is that our range is negative pi over 2 to pi over 2. So it can either come in the first quadrant or rotating negatively to the fourth quadrant. So let me ask you this. Where is the sign a positive 1/2? But what value? It's either pi over 3 or pi over 6. Which one? What? Pi over 6. Okay. Negative 1/2. We're going to rotate down to the fourth quadrant to negative pi over 6. Yes, I know that the sign of 7 pi over 6 is negative 1/2. And I know that the sign of 11 pi over 6 is negative 1/2. But when we're talking about arc sine or inverse sine, the value has to come between negative pi over 2 and pi over 2. Okay, so we have to choose negative pi over 6 in the fourth quadrant. Okay. Let's talk about this one. The inverse cosine of negative radical 3 over 2. Please remember that the range of the inverse cosine is 0 to pi. That includes the first and the second quadrant. So what angle has a ratio for cosine of negative radical 3 over 2? How about in radians?
5 over 6.
Okay, so since it's negative, it can't be pi over 6. Instead, since it's negative, we have to go to the second quadrant, and we'd say, what's 115 radians? Because you were right, it's 115. What's 150 in radians? Okay. Yes, at 11 pi over 6, the cosine, or excuse me, at 7 pi over 6, the cosine ratio is negative 1/2. However, the range of inverse cosine is 0 to pi, so we can only pick values between the first and the second quadrant. How about this? Inverse sine of 2. Here we go. Inverse sine of 2. A question for you. What is the domain of the inverse sine? Negative 1 to 1. Is 2 in between negative 1 to 1? No, okay? So we cannot, okay, we can't calculate it. This is undefined. If you put this in your calculator, you would get an error, okay? Our domain has to be between negative 1 and 1. This will not work. Tyler's trying it out to see what happens. It says domain error, doesn't it?
It does.
All right, let's go back up to here. Our cosine of radical 2 over 2. This is asking you, where's the cosine? Radical 2 over 2. John? Pi over 4. I like this one. Inverse cosine of negative 1. This is asking you, where's the cosine? Negative 1. What? Pi. Inverse tangent of negative 1. There's a place. What kind of angles is the tangent, either a 1 or negative 1? Some sort of pi over 4 angle, right? Now, the inverse tangent has to come between negative pi over 2 and pi over 2. So either in the first quadrant or down into the fourth quadrant. So where would that be? So negative pi over 4. So we have to rotate down into the fourth quadrant for tangent to be negative. Okay. All right, with your calculator, let's go ahead and practice some things. Okay. Go ahead and put your mode into radians. It should be in degrees from last night's homework. Put it in radians. If you see the arctangent of negative 8.45, what do you do in your calculator? Okay? Tangent inverse of negative 8.45 in radians. What is it, Kevin? Okay? I do want you to notice, okay, the inverse tangent has a domain of all real numbers, so we can plug anything in to arctangent. It's the inverse sine and inverse cosine that are very picky. Okay? How about this one? The inverse sine of 0.2447. Michael, what do you got for us?
0.247.
It's radians. We don't need a label. What about this one? Arc cosine of 2. Look at all you guys putting it in your calculators. Okay, did anybody stop and say, oh, that's not going to work? On a calculator portion, it's not a big deal if you don't notice that because your calculator is going to tell you what's happening. But it's important for you to understand the message your calculator is sending to you. What does your calculator say when you try to do that?
Error domain.
Error domain. 2 is not in the domain of arc cosine, so it's not going to work. Yes.
So all numbers would be in this domain.
Yeah, the number you are plugging in needs to fit the domain, and the number you get out needs to fit the range. So now what we're going to do is look at combining functions together. Okay, so what if I had the sine of sine inverse? Do they automatically undo each other? Okay, unfortunately not always. Okay, if we have the square root of x squared, bam, bam, they cancel each other out, right? But if we want inverse sine and sine to undo each other, we have to have certain specifications met. All right? So what are those? Okay? If we want arc sine and sine to undo each other, sine and arc sine to undo each other, this is what has to happen. Okay? If we have sine of arc sine, they can cancel out as long as that x is in the domain, negative 1 to 1. And arc sine will undo sine as long as this y is in the range of arc sine. Okay. So go ahead and write that down and I'll talk through it again. So if we look at this one right here, since our sine function has to produce values between negative 1 and 1, then these two can cancel out each other only if this number is between negative 1 and 1. Okay. Since arc sine has to produce numbers between negative pi over 2 and pi over 2, the only way that these are going to cancel each other out is if y is between negative pi over 2 and pi over 2. Okay? If you want to be safe, then if we're working with like unit circle values, evaluate the inside and then plug it into the outside. If you're worried about whether it meets these rules or not, just evaluate each of them separately. Okay? But this is what has to be met. Okay? What's going to be different about our cosine and arc cosine? What's going to change? Okay. That y is going to have to be between 0 and pi. So since cosine gives us values between negative 1 and 1, the only way these two can cancel out is if x is between negative 1 and 1. Arc cosine gives us values between 0 and pi. So the only way that these two can cancel each other out is if this guy is between 0 and pi. Okay? If they're not, you're going to have to work step by step, which you can anyway. And then arctangent is going to be a little bit different once again. First of all, our arctangent has a nice domain, right? Tangent has a nice range. And so this is nice. Tangent of arctangent, they will always cancel out because tangent has a range of all real numbers. So yay, this is nice. We don't even have to think. Tangent of arctangent automatically cancels out. However, arctangent cannot cancel out with tangent, or tangent can't undo arctangent unless that angle is between negative pi over 2 and pi over 2. What? Right. Because we have the asymptotes at pi over 2 and negative pi over 2. So I have 5 examples for us to do. Some of them are unit circles, some of them are not. Are you ready? So ready. Okay. Here we go. Tangent of arctangent of negative 5. What did I tell you about tangent of arctangent? They will always cancel. We don't even have to worry about what that number is. Automatically, they will undo each other. Next one, arc sine of sine of pi over 3, 5 pi over 3. Do these automatically undo each other? They don't. This angle is not between negative pi over 2 and pi over 2. So we have to take this one step by step. Arc sine cannot produce 5 pi over 3 as a value. Okay? So instead, we need to evaluate this. What is the sine of 5 pi over 3? Without a calculator. unit circle value. What's the sine of 5 pi over 3? Sarah. Almost. You're missing one little thing. Yes, because 5 pi over 3 is in the fourth quadrant, right? Okay. So we have the arc sine of negative radical 3 over 2. Okay. So remember, arc sine is either positive in the first quadrant or negative in the fourth quadrant. We have to rotate down to the fourth quadrant. So what is the arc sine of negative radical 3 over 2? Rotate down to
Isn't it 62?
negative pi over 3. Yes. I want gradients, sorry. But yes, you're right with 60 degrees. Okay, so since it's negative, we rotate to negative pi over 3. Cosine of the inverse cosine of pi. The inverse cosine of pi. Yeah. It would be nice, but I kind of threw a trick at you. The cosine has a range of what? That would be the inverse cosine. What about the cosine? Our range is negative 1 to 1, which means this answer has to be between negative 1 and 1. If these cancel out, it's pi in between negative 1 and 1. Okay. Also, the inverse cosine, we can only plug values in between negative 1 and 1. Pi is not in the domain of inverse cosine. Now, if this was kind of a mean example, but I wanted you to think, if this was the inverse cosine of the cosine of pi, then it would equal pi. Okay. Okay, we're going to do this one. Cosine of the arc sine of negative 3/5. Now, are these unit circle values? No, they're not. Okay? Which means we're going to have to draw a picture. Okay? So let's think about this angle right here. What quadrant is that angle going to lie in? It has to be the fourth, because arc sine only comes from the first or the fourth quadrant. So let's draw our fourth quadrant. Our sine ratio is 3/5. What is this side right here? 4. Now, I'm going to go ahead and label this as a negative 3, since we had to travel down 3 to get there. Okay. So now we're going to evaluate the cosine of theta. The cosine of theta. All we have to do is look at our picture. What is the cosine of that angle? 4/5. So So it's a matter of drawing your triangle in the correct quadrant and then evaluating the trig function from there. Any questions on how? Can you? Okay, we know that it goes in the fourth quadrant because, thank you, arc sine only has values in the first or the fourth quadrant, and so since it's negative, it has to be the fourth. Okay, if it was an arc cosine, it could only be the first or the second, so those would be our only two choices of quadrants to draw our triangle. Does that make sense? Okay. What I'm going to have you do is I'm going to have you write down your homework. And we have 3 minutes in class. I'm going to give you a little slip of paper. But I want you to evaluate 6 of these inverse functions on your way out the door. Okay? Just to kind of practice these before we leave. We have 3 minutes. I know you're not going to start your homework. So I'm going to make you practice something new. Okay. So I will check your exit ticket, if you will, when you have those ready.